Hey, hi YouTube. How are you? I hope you all guys are doing great. In this video, we are going to cover advanced RAG techniques. Uh, you might not feel that advanced RAG techniques are important until and unless you need it. What I mean is, maybe you are an LLM or maybe Gen AI developer and you are at your initial stage. Maybe you are doing some POC or learning about it. Maybe you are creating a very basic RAG which doesn't have a lot of data source, which doesn't have static and dynamic both type of data, or your business doesn't need this kind of requirement, which is not very complex, where you doesn't need prioritization, or maybe you don't need some kind of like re-ranking. Then you might feel that this kind of advanced RAG techniques are useless. But trust me, whenever when your business will become more complex and you will feel that we need some the trivial or the generic RAG is not working that perfectly, then definitely this advanced RAG techniques are going to be very helpful for you, where you have a lot of data source, where you have multiple static dynamic data, where your business needs prioritization. Whenever you are suggesting some products or whatever it is, you need prioritization or you need re-ranking, then definitely this advanced RAG techniques plays very important role. So that's why it's really important. So we are going to cover today this RAG techniques, and I'm not going to cover the implementation part because the video itself will become very long, and still it will be very long. But if even if I cover this implementation part, the video will become very long. Okay, so I think we should not cover that in this video, but if you need the implementation video of it, then definitely I will create implementation for each technique. Before moving to this, a huge shout out to this Medium article, which is Advanced Rec Techniques. It is by Tarun Singh, so very beautifully written, and you can also buy his book. And he a great author. He has a lot of different books, and this is actually on RAG. And you can also buy the Kindle version or paperback version. So I prefer the Kindle version. So it's good. You can go through it. A lot of things are there. So a huge shout out to you. Please, I will provide the link in the description. Go and you should check this Medium article once. Okay, so let's move to the advanced RAG techniques. But let me just revise what actually RAG is. So RAG combines the strength of retrieval-based and generation-based models to improve information generations. So it basically has two steps. First one is the retrieve, so where you will have to retrieve the data, and then we have to generate. So this is the very basic RAG that we use to have it. So retrieve is like it first retrieves the relevant documents or passages from a database or knowledge source. It can be multiple knowledge source. Then it generates. It then uses the retrieved documents to generate more accurate and informative response that we mostly done by LLM. So I can give you example, like imagine if you have you ask a system like what are the symptoms of the flu, then something you will retrieve from the whatever data you are having. Let's suppose you retrieve that the system searches a medical database and finds relevant documents that describe flu symptoms. Now you have to generate. So using the information that has been retrieved for flu, using that information for these documents, the system generates a response. Like the symptoms of flu include fever, cough, runny and stuffy nose, muscles or body aches, headaches, and fatigue. So this is what generation is. No, why it is useful? Because for the accuracy purpose. By grounding its response in real documents, the system can provide more accurate and relevant answers. And it is also detailed. The generated response can include detailed information extracted from the retrieved documents. And whenever you are having the private data, then definitely RAG is really important, because the models like GPT-4 or mini GPT-4o or whatever haiku model you are using, they don't know about your personal or private data. Okay, because they are trained on the data that is publicly available. So at that point, RAG is really, really important, which is the very basic RAG that you are working on, which is you have the documents. Now from these documents, you basically use an embedding model. From this embedding model, you basically create a vector store. Then whenever query comes, again it passes to embedding model. From vector store, we retrieve some context. And from this context, we pass to the LLM. The context and query both are passed to the LLM, and then we get the final answer. So this is a very basic RAG that you use to, and if you are at very initial stage, this is how your RAG will be also looking like. But this is not the best one. Okay. Now, the, this if you are trying to level up your RAG, then definitely the first and foremost step that you might feel that it's important is the chunking one. Okay, chunking, or you can say vectorization. Okay, so first of all, let's see what actually chunking. I think you might be knowing what actually chunking is, but just let me revise it, and then we will also see how it affects. So chunking and vectorization are fundamental to advanced RAG process. So chunking is to divide the large text documents into a smaller, manageable, meaningful pieces. So let's suppose you are having a very long document, then you convert it into different chunks. Okay, it will be smaller chunks, which will make a lot more meaning. Okay, so what is the importance of this is transformer models like BERT, GPT have a limit on the length of input they can process. Chunking ensures each piece fits within this limit and retains meaningful context. Okay. Um, so let's suppose you are using a model. Okay. And let's suppose the size of model, maybe if it accepts the input token as, let's suppose, 3K input tokens. Now your document is, let's suppose, having 6K words or characters. Now the whole will not fit into this context. Okay. Then you have to create the chunks, and then the chunks will be passed to the model, the meaningful chunks. Now you might say that, hey, there are a lot of models now like Haiku, they have very, very huge context, like maybe 100K, 200K. But remember, if the context is big enough, then the accuracy decreases. And also, if you pass everything in the model, then cost will also increase, latency will also increase, because it depends upon both the things, input token and output token. So it will increase your price as well as it will increase your latency. So it's a not good thing. Okay. Now, what are the different techniques of chunking? First one is the very basic one. Okay, so the basic one is like splitting the text into sentences or paragraph, okay, which you might be also doing. But there are a lot of advanced chunking strategies are also there, like using text splitter tools that intelligently determine chunk boundaries to preserve semantic meaning. You can also optimize, like the size of each chunk should match the embedding model capability, balancing context completeness within the precision of embeddings. Okay, so and definitely chunking itself is a very, very huge topic. You can go to the LangChain website and there are a lot of things, but I prefer this LangChain documentation where they have explained about a lot of fixed size chunkings, semantic chunking, a lot of different chunking strategies are there. I can explain in another video. Okay. So this is what advanced and basic chunkings look like, and definitely basic chunkings doesn't make a lot of sense in advanced use case. So you should go with the advanced chunking. Okay. So what can be an example of this chunking is like the lengthy document. Let's suppose you have a lengthy document on climate change, and you might chunk into different chunks. Like first chunk is about introduction, second is about cause of climate change, third is effects of climate change, and so on. So whatever model you are using, just understand its context size and its capability. Like every model doesn't, if let's suppose if a model is having context size of 3K and you are supplying the whole 3K tokens, then maybe the model will not accurately work. So and also the price will be high, the latency will be high. So it betters to have a proper chunking where your semantic meaning is not lost. Okay, let's suppose you have two chunks for a document, and one part is here and one part is here, and both should be at the same place. Might be in some cases. So in this case, the integrity is lost because these two texts should be at the same place. So that's why, depending upon the data, you should always determine the chunks very, very carefully. And a lot of chunking strategies are there. I can explain in some other video. Okay, because it is itself a very, very huge topic. Then second is vectorization. So let me write this vectorization. Red looks good. So what is the purpose of vectorization? To convert the text chunks into numerical vector representation. So let's suppose you are having some chunks, you pass it to your embedding model. And okay, this is not the embedding model, this was the LLM model. Okay, so embedding model, and then it will convert it into numeric chunks like 0.2, whatever it is. Okay, it depends upon the dimension of the model. Okay, so it will convert into numerical vectors. What is the importance of this? These vectors capture the semantic meaning of the text, making it possible to compare and retrieve relevant information. There are a lot of models like BG Large. It is known for capturing nuanced semantic details. Then E5 embedding families are also there. Okay, like there are also another set of models efficient for semantic representation. Then you might ask that how we can be updated. So there is a MTEB leaderboard where they update each and everything. It is, I guess, it's a space on Hugging Face where you can see all the latest embedding models which are the most powerful. So selecting this correct embedding model is also very, very important for your RAG. Okay, so it regularly updates with top performing models for embeddings, ensuring the use of latest and most effective technologies. Okay, then what example I can give is like, let's suppose using a model like BG large, the chunk like initially if you have a chunk of climate, it can be converted into vector representation like this. Okay, very basic one. Why these steps are very, very important? So chunking ensures that the text is processed within model limits while preserving the meaning, because if your data is wrong, then definitely you can never expect a correct answer. Vectorization translates the chunk into form that allows the RAG system to retrieve and generate accurate and contextually relevant responses. So that's why this both techniques are really, really important for advanced RAG techniques. Now let's see the search index. After this two important parts, here comes the one more important part, which is search index. So search index is basically a collection of data that helps a search engine understand where and how to find information quickly. So when you perform a search, the engine doesn't scan every document in the real time. Instead, it looks through this pre-built index to find relevant documents. Let's suppose you have a data and you chunked into, let's suppose, 100 different chunks. Okay, what do you think? Like whenever a request will come, do you want to search in the whole? So what I mean to say is, let's suppose this is basically a document. Okay, these are the chunks. Okay, now if a query comes, okay, let's suppose a query has been entered. Now it will look into the whole document. Okay, then it will let's suppose you are having top as 2, which we call as top k. So it retrieved the top two most similar documents, and then we pass it to the LLM, and we pass this query as well this context to the LLM, and LLM gives us the final output. So this is a very basic, we uh, which we call as vector store index. Okay, so you might have also heard about this flat index. So flat index is a simple method. Um, this all things will come under, actually this vector store index is the topic name. Okay, flat index is this one. Okay, so don't get confused. A simple method where all the vectors are stored in a flat structure, and searches are performed by comparing the query vector with every stored vector. Okay, so this query is also converted into vector actually. Okay, so query will be passed to embedding model, and this embedding model will convert a vector, and that vector will be matched with vector. Okay, so let's suppose I can give you example for this flat index is, let's suppose you are having maybe 1 million text vectors. Okay, the query vector is compared to all 1 million vectors to find the closest match. This is computationally expensive but very straightforward. What will be the time complexity? It will be around order of n. Okay, but do you think it is a good one? I don't think so. So that's why another vector, you can say technique, vector storing index technique comes into the picture, which is called as ANN. What is ANN? Approximate nearest neighbors. So you might have heard about phase. Okay. So it is a library that enables efficiently similarity search and clustering of dense vectors. So where it can be useful, like using phase, you can index millions of vectors and perform fast approximate nearest neighbor search, reducing the search time or time complexity significantly. There are other libraries also. So nmslib, I guess the name it is something like that. So it's another library which is optimized for high dimensional vector search. Then we have annoy. Okay, so again, it is also designed for fast retrieval of nearest neighbors using memory mapped files. Then this is one is famous, OpenSearch or Elasticsearch. Both offer vector search capabilities integrated with traditional search features. So then vector database. So we have a lot of vector database like Pinecone, Weaviate, Milverse. This provide scalable solutions for storing and querying vector embeddings. So you can use any one of them. Okay, I generally prefer this OpenSearch or maybe Pinecone. Okay, but you can use anyone. Phase is also very good for in-memory vector store. So choosing this is also very, very important. You might be thinking that why I am going through all this to make you understand that why flat index is not good, why you should use these things. Okay, you can also create your own vector store. It's not a big deal. But if someone has already created, which is a very, very good one like OpenSearch or Pinecone, why should not we use it? Because they use this ANN techniques and it's far better than flat index. Okay, now we have some more advanced indexes like we have, it is called as hierarchical index. So by the name, I guess you might be understanding it. So it is a two-tiered system where the first index contains summaries and the second index contains detailed chunks. Okay, so it if I can draw it, it will be something like this that um, let's suppose this one are the summary. Okay, this will be index of summary. Okay, now all the summary, uh, so the next part it will be having more of them. Okay, so this part, let's suppose we call it as 1, it will have this A as its child. 2 will have 3 children, let's suppose B, and we have more chunks with, this is the detailed chunks. Okay, so initially it was in the index of summary, now this is detailed chunks. Let's suppose we call it as 3, so C is a child of third one. Now if someone asks a query, if some query is fired here, okay, and first of all we iterate through this, so the index of summary, let's suppose it matches this one, so now this whole, this two will be getting selected as a context for the LLM. So this will be the top relevant documents. Now the query and the context will be passed to the LLM to finally get the response. Okay, so it's quite easy because let's suppose you are having only index summary maybe 100, and each one is having two childs or maybe 10 childs, so this will be having 1000 part. So it's quite easy because you have to just iterate in this 100 because they are the having the summary of the whole index which is here. Okay, so it's good. So example can be like index contains document summaries, and tier 2, once the relevant summaries are identified, a deeper search is performed and on that corresponding detailed chunks that I have explained. So what is actually the application of it? Like searching for medical articles, like we will carry the same example, flu example. Okay, so the first year filters, let's suppose by general topics like flu symptoms. Okay, let's suppose here there is flu symptoms. Now, if some user is asking about flu, then we will just search in this 100 part where a lot of symptoms are there. One of them is flu symptoms, and in this symptoms, maybe we have a depth knowledge, a deeper knowledge, and the second tier retrieves specific sections detailing each symptom of flu. So it's quite easy and it's quite efficient. Okay, now we have a hypothetical question, and which we also called as hybrid approach, which is really good. Okay, and at whenever you will have a complex business approach, then hybrid search or hybrid approach will be, sorry, really helpful. Okay, so what these hypothetical questions are like, it generalize the potential questions related to each text chunk and store this instead of original text vector. So if I can give you example, like for chunk about flu symptoms, hypothetical question might be what are the common symptoms of flu, or how does the flu manifest in patients. Okay, so this how hypothetical questions we design and map it to the chunks. Now, in this hybrid approach, what we do is we generate a hypothetical response to user queries and using this as additional data points for refined query. Like what we can call it in this hybrid approach is like it can be combined with both. Okay, the lexical search as well as um, the semantic search. Okay, currently we are doing only semantic search, but lexical plus semantic both can be important and it can be combined as hybrid approach. Okay, so for a user query about flu treatment, hypothetical response might be generated and vectorized to find the best matching chunks in the dataset. Because it's maybe currently if you go to any searching index, you might find the lexical search. They don't have semantic search. Because if you go to Amazon, I'm not telling Amazon, I haven't checked currently their searching techniques, but I'm just giving an example. Forget about Amazon, they are very good. Okay, so let's suppose we are having a search engine where I go and ask about some product, ABC product. It is, let's suppose, for rickets. Rickets is caused because of deficiency in vitamin D. Now it will give me the product. Now if I go and ask lack of vitamin D, suggest me a product, then definitely it should suggest this ABC product, because this ABC product is for deficiency of vitamin D, and I'm asking it in a long text format, but it will never get the answer because they are not using semantic search, they are just using lexical search. But in some cases lexical search is also very efficient. So that's why combining both lexical plus semantic search, it forms a hybrid approach, which is very important. And I guess a lot of vector stores like Pinecone, and if I'm not wrong, OpenSearch both supports hybrid approach. So it's really important to think in that way that if your business need it, you should switch to it. Then we have this was all about I can say this was all about um, this vector search index. I guess this was the topic. Yeah, vector search index, vector store index. Now we are going to see another technique which is also important, which is called as context enrichment techniques. So uh, what actually context enrichment techniques are? Embedding individual sentence and extending the context to include neighboring sentence. So for example, there is a sentence one which is the flu, just hear it, the flu is a common illness. Now we have a sentence 2. Symptoms include fever and cough. The sentence window will be embedding both the sentences together to retain connection between the illness and the symptoms. Okay, so it will be something like this. So let's suppose you are having a query and you have a huge document. Okay, you have a lot of documents. Now let's suppose this part matches. Okay, so if this part matches, so the whole may be until this point. Okay, so the extended context is going to the LLM to answer it in a better way. Okay, maybe it can be not helpful for your purpose or for your use case, but it see, listen, like every technique is not useful in every use case, but at some point you will need it. Okay, you might be thinking that okay, it is of no use, but at some point you will feel that this technique is going to be helpful. Okay, so like in the example that I have given, the first one is like the flu is a common illness. Then the sentence two was symptoms include fever and cough. And if someone came ask about illness or symptoms, then the combination of this both sentence will move into the context, and it will enrich the context. Okay, if you will just send this part, maybe your context is not that enriched, but if you send some more context, okay, I know it is not that good because it can increase your latency and increase your input token, but sometimes it can increase your accuracy. Okay, so that's why it's really good to enrich your context. Okay, then some more techniques are there like auto merging retriever, which we call as parent document retriever. So it is parent document retriever. So it retrieves the smaller relevant chunks first and then merge them if they relate to a larger context. It is just opposite to that parent child one. Okay. So I can give you an example where let's suppose initial retrieval was about flu symptoms. Okay. A very basic one, flu symptoms. And another one was treatment. So both were retrieved separately, flu symptoms and treatment. Now there will be merged context, and the merged context will be providing information about symptoms as well as the treatment. Okay, so if I draw it, it will be something like this. There will be a query, and then we will have vector store of all child or leaf chunk vectors. Okay, now it will from this vector store of all child or leaf chunk vectors, we will retrieve top k element child chunks. Okay, let's suppose top k included uh, only this one. Okay, now this child chunk will have their parents, so the parent chunks will be linked to the retrieved child chunks. Okay, if this is only retrieved, then we will having the parent of them. Okay, so this whole parent will be now passed to the LLM with this query, and it will give some output, as simple as that. Okay, then we have fusion retrieval, blending the old and new one. Okay, so it is again the hybrid approach. Okay, we call it as basically this hybrid approach only comes under this thing where you can combine the traditional keyword search as well as modern vector based search techniques. So traditional search includes like I think you might have heard about TF, IDF, and we have also have BM25 or BM25. It uses a keyword frequency and importance to rank documents, and we have vector-based search. Vector-based search includes it includes semantic search, so we can combine both. So that's why we name it as fusion retrieval. Okay, I just have a fancy name. Okay, we call it as hybrid approach only. Fusion retrieval. Okay, so a lot of vector stores they directly support it, so we should use it. Okay, so let me summarize till this point. So first of all, we have seen vector store index. Okay, so it efficiently stores and retrieves vectorized content using advanced indexing techniques. Then we have seen this hierarchical index. So it improves search efficiency by filtering through summaries before diving into detailed chunks. Then we have hypothetical or hybrid approach. Okay, it's aligned semantically used by generated questions or response for better matching. You also call it as fusion retrieval. Then we have context enrichment techniques, like it provides richer context by retrieving and merging related sentence or document chunks. Okay, I know this context enrichment can be not that helpful in some use cases, but it can be helpful for in other use cases. So it's better to know this, so that if you will not know this, then you will never able to apply it. Okay, so till now, we have seen a lot of things where we have come under the like the retriever part. Okay, now um, let me give you an example. In some use cases, even after retrieving the data, you need to re-rank it. Okay. If let's suppose you are having a business use case where they have a strict action to suggest some products in a specific sequence. Okay. They want to prioritize some products, then definitely you need to re-rank or filter it. So filtering also enhance retrieval precision. So the next one is uh, we call it as re-ranking and filtering. Okay, so after initial retrieval, enhancing the precision of results is crucial. This is done through re-ranking and filtering using various post or pre-processing techniques. If you have used OpenSearch, they already support this re-ranking, filtering, post-filtering, pre-filtering. Okay, so we have post processors like the systems like Llama Index offer a range of post processors to fine-tune retrieval outcomes based on similarity scores, keywords, and metadata. Re-ranking models are also there. Like it incorporate additional models such as LLM or sentence transformer, cross-encoders, or external services like Cohere to rank or to re-rank the results for better relevance. And also there is metadata filtering, which is really useful. It adjusts the results based on metadata attributes like recency, ensuring that the most relevant or timely information is prioritized. So I know this re-ranking, filtering, this itself is again a huge topic. I can create a video on it, like pre-filtering, post-filtering, filtering based on metadata. Then maybe this all are not. It may be that this whole thing is not useful for you in your use case. Then you have to create your own custom prioritization or re-ranking logic. That is also important. So okay. I can't cover all things in this video. I guess itself the video is getting very long. Okay, but this is important, and you can find all these things in internet. Okay, but I can create a video if you need it. Okay, then the example it can be initial retrieval, like retrieve documents based on initial query. So if you fired a query, then some documents has been retrieved. Then you have to re-rank is using a cross encoder to re-rank these documents based on the relevance. And then maybe it's 1, 2, 3, 4. Then you have re-rank it as 3, 2, 4, 1 to get a more better answer. Then you are applying filters. And after that, you can prioritize your documents with latest information. And after, let's suppose, applying this filtering, only 3 and 4 were important for you. So now the ranking is also done in this stage, and the filtering has been also done in this stage. So this is also really, really important in your RAG. Okay. Then we have query transformations. So this is also quite important, and it's very, very important. Okay. So you might have seen like, okay, we have maybe there is a query. Okay, let's suppose there is a query, suggest a shampoo. This was the first query. Now what will happen? Definitely a basic RAG will happen. I'm not going into detail. And you got an answer as you got an output as this XYZ shampoo is brilliant for you and blah blah blah. Now, now what the next query can be? Is it safe? Sorry, is it safe for an baby? Now, this query needs to be reformulated. Okay, now we will reformulate it. This is the history part. This history will come into here, and it will this latest query will be also going to here, and this is itself is a LLM. Okay, now it will reformulate the query, and the query will become this only not this the this query as well as this output. This whole will be as a history, a user conversation. This will be passed into this reformulated query, and it will create a question like, is XYZ shampoo is safe for baby? Now this question will be passed to the RAG. So that's why the query reformation is very, very important to have a better context if you are creating a conversational bot. So query transformation techniques uses LLM to refine user inputs, improving the quality and relevance information retrieval. So it can be like subquery decomposition, break down the complex query into simpler subqueries, process them independently, and synthesize the result. Okay, so or definitely it's one of them use case. You can also have subquery decomposition, okay, where the big query can be decomposed into smaller one. Then we have step back prompting, where it generates a broader or more general queries to retrieve higher level context, which is then combined with the specific query context. We also have query rewriting, which reformulates the initial query to enhance retrieval effectiveness. So let's suppose um, I have given you example for it. Maybe for a step back query, it can be like maybe the query is like, which position did XYZ hold from this particular date to date. Okay, maybe like, which position John holds in company from uh, our specific date. Now the step back query will be, which position have John held in his career or in this company. Okay, so this is a step back query which generates a broader or more generalized way, because this one were more specific. This one was more generalized because there was also a date filter here, but there was no filter. No, it was more generalized. Okay, it was just talking about the position. Okay, so that's why step back prompting or step back query is also really, really important. And this whole query transformation is done by our LLM only. Okay. I guess I have already explained you this chat engine one, which was the follow-up question. So we have to reformulate it. Okay. So like context chat engine retrieves relevant context along with previous chat history to inform the LLM response. We have also condense plus context mode, like it condenses the chat history and the last message into a new query, retrieve relevant context, and passes it along with the original message to the LLM that I have just explained you. Okay, if you want to learn about memory, I have also created some 2 to 3 videos on memory on LinkedIn, where you can use different types of memory. Okay, and this memory plays a really, really important role. But in our use cases, we don't use directly this LangChain memory. Instead, we use something like MongoDB or Redis to store our data. Okay, to store the conversation. Okay, so I have just given a follow-up question, I guess, the sample one, so it's fine. Now, what we can have is query routing. Okay, so it comes now the agent part. Okay, if you are knowing about a bit about agent, it can be easy for you to understand. Okay, query routing. So a query routing is a sophisticated technique in retrieval RAG systems where an LLM or an intelligent agent decides the best subsequent action to take based on user query. This process helps in optimizing the retrieval and synthesis of information, ensuring that the response is both relevant as well as comprehensive. So, like strategic decision making, the system dynamically chooses the most effective method to handle the user query. This could involve summarizing information, searching specific data indexes, or exploring multiple routes to compile through response. So, like maybe I can give you example for data source selection. Okay, so the query router decides which data source or index to search based on the query's document. Let's suppose you are having a lot of different data source. One can be for finding about information about climate, one is for news, one is for sports. Now, whenever query will be fired, the agent will be able to decide or to route the message where I have to look. If the question is related to news, it will go to the news index. If the question is related to climate, it will go to climate index. So this is particularly useful in the systems where diverse data storage solutions such as vector store, graph database, or relational database are there, because at some point of time your business would need the static as well as dynamic data. So this dynamic data part can be handled by this routing or the agents. Now I can give you more explanations about like let me give you some more examples like summarizing information, like maybe summarizing information. Okay, my writing is not good. No way. Okay, no problem. Let's suppose the user asks what are the main benefits of using OpenSearch for vector indexing. So the action will be the query router may decide to summarize large documents about OpenSearch, extracting the key benefits and presenting them concisely. What will be the process? The process will be very simple. The LLM retrieves multiple detailed documents about OpenSearch. Then it can synthesize the information into a summary highlighting the primary benefits such as scalability, integration capabilities, and performance. Okay. Now there can be a lot of different use case. Okay, like search specific indexes, like let's suppose there is a user query where the question is like where what were the sales figures for our product in quarter 1 2024. Okay, the action will be the query router might direct the search to a specific database or index that stores sales data for quick and relevant results. What will be the process? The process will be very simple. The system will identify the database that contains sales records. Okay, and it executes a targeted search query where within this database to retrieve the data of quarter 1 of 2024 sales figure, and then the results, and then are formatted and presented to the user. Simple. Okay. I guess this much is important. Or yeah, maybe there are multiple routes are also there, like if the user asks very complex questions like compare. Okay, compare the price of A product with B product. Okay, so now you have, let's suppose this price is in another data source and this price is in another data source, then you have to like first of all decompose the query, and then you have to select the source and then the synthesis of whatever response you are getting and giving the combiningly. So sometimes this multiple routings are also there, so it's quite important for having a efficient rag. Okay, then so I guess we have covered these agents one. Agents are really important. You can learn more about agents. You should include agents in your rag to have and it's not like agents are that much important, because if your use case is not very complex where you don't need automation thinking, where like routing and something like this, then agent can't be useful, as agents increase the time as well as it also increase LLM calls because they have their own reasoning. But if your use case is complex like this, where you have more than two intents and you have more than two things to compare or sort and something like that, then in that use case agents can be really very helpful. Okay, so it basically agent enhance the LLM capabilities by using additional tools and tasks, forming chains of LLMs to handle complex tasks. Okay, so I guess that's why it's important. Okay, then we have response synthesizer. Okay, so it is for crafting the final answer. Okay, so we have response synthesizer. Okay, so this response synthesizer generates the final response based on the retrieved context and the initial user query. So we have iterative refinement, which break down the retrieved context into manageable chunks and subsequently refine the response. There is context summarization, compresses extensive context to fit within the LLM's prompt limitations. Then multiple answer generations, which produces several response from different context segments and synthesize into a unified final answer. Okay. The example can be like, what are the benefits of using open search for vector indexing? So the synthesized answer will be it combines information from multiple documents about open search features, performance, and use case to form a comprehensive and final answer. Then last but not least, we have evaluating the RAG response. This is really, really important. Okay, because if you are not evaluating your RAG response, and if you are not improvising your RAG response, then definitely you are at the wrong page. Because no matter how better RAG application you have created, at some point of time it will hallucinate, and some point of time it will fail. So evaluating DEX in terms involve metrics such as relevance of retrieved context, groundness of the answers, and overall relevance to the user's query. You can have a lot of F1 scores, or a lot of different scores are there. Okay, so you have to like measure them all. Okay, like hallucination index, answer relevancy, a lot of things are there. Okay, so you have to keep eyes on it. Okay, so effective evaluation frameworks like DPWell, okay, it's a very good framework to uh, eval your LLM response. Okay, I have already created a video on it, so you can watch it. Okay, so if you need, okay, it's not compulsory. Okay, so you can watch this DPWell video where I have explained you how you can evaluate your response, because evaluating through human is very tedious job, and at some point of time maybe human can also fail at some point, but machines doesn't fail. In this point LM fails because they have facing hallucination and all, but with time being the accuracy will increase, and definitely this kind of frameworks will be at peak. Okay, so definitely effective evaluation frameworks like this consider this metrics eventually and examine their interaction within complete React pipeline, because we have to, if we do it manually, then definitely we have, let's suppose we are doing for 10 to 20 metrics, we have to create logic for all them and then we have to run it. But if someone has already invented it, then there is no use of making it again. Okay, and definitely this all frameworks are on local, so you can blindly trust them, they are open source. So advanced RAG techniques significantly enhance the retrieval process, making it more interactive and adaptable. By integrating these all techniques, where from starting we have seen about we have seen a lot of different things like chunking, then vectorization, then how to select the vector store index perfectly, and then we have seen a lot of things like the flat index, hierarchical index. Then we have seen the hybrid approach, and how we can enrich our context, then how we can have better retriever, like maybe like parent document retriever. Then how we can include a fusion retrieval, which can be the blend of old and new techniques, where we can use traditional search as well as the vector based search, then re-ranking and filtering, and then we can have query transformations, and which we call as flow follow-up questions to create a standalone questions, which is really, really important if you are creating a chatbot. Then query rerouting and using of agents, then synthesizing the response correctly, and then evaluating the RAG performance. These whole things are really, really important. And if you combine whole things, then definitely your RAG will be much better. So that's all for this video. If you have any doubt, you can ask in the comment section, and a huge shout out to that page, the Medium link. I will give in the description box so you can read it and follow him also. Great guy. Okay, so that's it. And if you need a separate video for implementation of all these things, and to look up like how we can have different chunking strategies, how this different vector index looks are better than like how the vector index of phase is better than the flat index, how we can learn about nms lib or something like that, or how we can create agents, how we can create our custom agents. So definitely I can create a video on it, because I can't cover all things here only. So this was more about the theory part, where we can have a lot of information about how we can create advanced RAG techniques, what we should follow while creating, what should we keep in mind while creating our RAG application, because the data is really, really important. If you don't have a proper data, you can't expect good things from it. Okay, so this was all about advanced RAG techniques. I hope you liked it. If you liked it, please subscribe it, because that's the solo motivation for creating videos. Okay, I'm just joking. Yeah, I like to create videos. That's why I create. Okay, so that's all. Meet you in the next video. Till then, bye bye. Thank you.